Very good morning, student. Next problems 6 from the current electricity lesson. Three identical lamps, each having a resistance R, are connected to the battery of EMF as shown in the figure. Suddenly, the switch S is closed. Question number 1. Calculate the current in the circuit when S is open and closed. Second question is, what happens to the intensities of the bulb A, B and C? The third question is, calculate the voltage across the three bulbs when S is open and closed. Then the fourth question is, calculate the power delivered to the circuit when S is open and closed. Does the power delivered to the circuit decreases, increases or remains same? So the first question is current in the circuit which S is open and closed. According to the Ohm's law, already we know the formula. V is equal to IR. Here V is nothing but psi. Psi means EMF of the cell. EMF of the cell is nothing but V, otherwise called potential difference. Here R1, R2, R3 are all same resistance. That is why R1 is equal to R2 is equal to R3 is equal to R. Three lamps are connected in series. RS is equal to R1 plus R2 plus R3, because already know the formula. Resistance in series RS is equal to R1 plus R2 plus R3. Here all the resistance are same. That is why R plus R is equal to 3R. When switch is open, here this switch is open, three lamps are working condition. So I is equal to V by RS is equal to psi divided by RS value. What is the value of RS? 3R. Here psi by 3R. When switch S is closed, then no current flow through the lamp C. Why? Because the circuit should be closed, means only A and B lamp only in working condition. Then C, it will not working during the switch is closed, should be closed. So the equation is I is equal to psi by only two lamps are working, that is why 2R, psi by 2R. Next, the second question is intensities of A, B and C. When switch is opened, three lamps are in series combination, so there is no change in intensity. So all bulbs having equal intensities. Second option is when switch is closed, means bulb A and B only in series, so the intensity across A and B increases and both having equal intensities. But the bulb C in parallel connection, hence no current flow through it, so the bulb C will not glow. The next third question, voltage. When switch is opened in series combination, current will be same. Already we know the formula. I is equal to psi by 3R. According to the Ohm's law, V is equal to I into R. Here I value is psi by 3R into R. R cancel to each other. Psi by 3. VB is equal to similar value. I into R is equal to psi by 3R into R cancel psi by 3. So similarly, VC also psi by 3. When switch is closed, closed means VA and VB are same value, but VC is equal to 0 because there is no current passing through this lamp C. So VA is equal to IR. Here I value is psi by 2R. Psi by 2R into R cancel to each other. Psi by 2. VB is equal to I into R. Psi by 2R into R cancel to each other. Psi by 2. But bulb C is in parallel. There is no current flowing through the lamp. So that is why I is equal to 0. VC is equal to I into R. 0 into R is equal to 0. The next last question is power. When switch open, what is the formula for the power? Power is equal to potential difference into current. That means P is equal to VI. Here for the lamp A, PA is equal to VA into IA. So VA, what is the value of VA? Psi by 3 into IA value psi by 3R. So psi into psi square divided by 9R. Since switch is opened, power is same. PA is equal to PB is equal to PC is equal to psi square divided by 9R. The second option is when switch is closed, what happened? PA is equal to VA into IA, psi by 2, here 2 because 2 lamp only working. So psi by 2 into psi by 2R is equal to psi square divided by 4R. Similarly, PB also psi square divided by 4R. But C is in parallel. VC is equal to 0. IC also 0. So PC is equal to VC into IC, 0 into 0, 0. So the power in C lamp is 0. Total power will increases. Thank you.